In this video, we'll be looking at Newton's laws of motion, linear momentum, and also kinematics formulae. So very quickly, this question just asks us to state Newton's 3 laws of motion, and this is very simple. It's something you just need to remember. So the first law is that an object will remain in a state of rest or uniform motion in a straight line unless acted on by an external or resultant force. That's something you just need to learn, right? The second law states that the unbalanced force on a body or in any object is equal to the rate of change of momentum. And finally, the third law states that if a body A exerts a force on a body B, then the body B will exert an equal but opposite force on body A. Alright, those are the simple 3 laws of motion. Again, you could get that definition in any textbook or any notes that you may have, right? So we don't need to waste time to actually write it down here and show you, right? So those are 3 easy definitions that you need to learn, right? So let's do some calculations based on these laws now. So in a crash test, a car traveling at a constant velocity of 26 meters per second crashes into a wall and is brought to rest. Calculate the initial momentum of a 70 kilogram test dummy in the car before the crash. So the first thing that we need to know here is what is momentum. Right? So the momentum is actually equal to the mass of the object multiplied by the velocity of the object. So this is a very easy calculation. So the mass is 70 kilograms and the velocity is 26 meters per second. So that is a very easy calculation. I will get that for you. So that's 70 by 26. 1,820, and the units, you have to put your units, right? Kilograms, meters per second. Okay, that is the unit for momentum. Calculate the average force exerted on the dummy by the seatbelt during the crash if the duration of the collision is 0.1 seconds. So in reality, the only formula that you need to know for force, right, because you need to calculate the force, right? Force is equal to ma, mass by acceleration. But we're not seeing any acceleration here, right? So, but what really happens during a crash is that the velocity of the car was 26 meters per second. And when you crash, obviously you come to a stop, right? And it went to 0. And how long did it take to crash? They said 0.1 seconds. So it went from 26 meters per second to 0 meters per second in 0.1 seconds. So that is actually deceleration instead of acceleration, right? So, you know, if you start to run, how long it would take for you to get from 0 to full speed? It would take, I don't know, a couple of seconds. Well, in this case, we went from a speed to 0 in a certain amount of time, and that is actually acceleration, except negative, right? So this is my initial velocity u, we call that u, and this is my final velocity 0. So we could modify this formula, F is equal to ma, and say F is equal to mass by final velocity minus initial velocity over time. And v minus u over t is actually equal to acceleration. Okay, so we didn't actually change the formula, we just used different numbers in our question to put it in the formula because we didn't have acceleration outright. We kind of needed to calculate it, and v minus u over t is how we calculate acceleration. So let's put this in our formula now. So the mass was 70, the final velocity was 0. The initial was 26 and the time was 0.1. So we will get 70 multiplied by, 0 minus 26 is just minus 26. Minus 26 over 0.1. And we could just work that out in our calculator. Right, it's going to be quite a large force actually. Right, so that's 70. Right, so I'm getting minus 18,200 newtons because it's force, right? You have to put your units. That's how we get that answer. Okay. With the removal of all protective features, the dummy was subjected to another crash test with the same initial speed. This time, it was subjected to a lethal decelerating force of 45,000 newtons. Calculate the duration. So again, we're dealing with force, dealing with time, crashing. We're using the same formula, right? So F is equal. We could put back MA and then change it to the V minus U1T, or we could just put V minus U1T, right? Because that's the one that we're using. If you look at the question, that's what they're giving us. They're giving us the force. They want us to calculate the duration, so our formula must have T somewhere in it. Right, we have the same speed and the crash, so the final speed is 0, and we have the same mass, right? Okay, so if they want us to calculate the duration, this means we need to make T the subject of the formula. So let's try to do that now. The easiest thing to do is to move this m over to that side. Alright, so to do that, we need to divide by m because m is being multiplied here, right? So this is going to be F over m is equal to V minus U over T. The next thing that we need to do is to move this T from below here. So we need to multiply both sides by T, or you could just cross multiply instead, right? So you put the T on that side, you bring the M up on that side. That will work as well. So let's do that. So we'll get Ft is equal to M multiplied by V minus U. And finally, to make T the subject of the formula, we just divide by F. So you get M multiplied by V minus U all over F. And that's how we could make T the subject of the formula and find it. So there's no need to learn off this formula. All you need to remember is the first formula, and you could make anything the subject of the formula and get what you want. Right, so now that we have this formula, we could just put all the information in there and calculate T. So M is 70. The final velocity is still 0. The initial velocity is 26. And F is 45,000. So we just put this in our calculator. So we'll get 0.04 seconds. Okay. Okay. For a popular amusement park ride, patrons board a carriage at the top of a high tower and are subjected to a wild ride of terror. Name and state Newton's law, which applies if the carriage is moving horizontally at a constant speed in a straight line. So this is actually Newton's first law, right? And I'm not going to write it out. You need to state which law it is and define the law, okay? If the carriage is in free fall, this is incorrect. This is the third law, right? Because if a carriage is moving horizontally that way, it actually exerts a force up. Remember, it wants the gravity is pulling it down, right? But the carriage will exert an equal and opposite force going up, right? That's the third law. And then for the carriage in free fall, it's the first law, because it will not stop until it's acted on by some external force, which would be like brakes or something, right? Okay. Calculate the length of time that the carriage in part A is allowed to free fall if it reaches a speed of 64.8 kilometers per hour from rest. Okay, so now we have some more kinematics formulae here, right? And it's actually a very simple formula we need to learn, right? So let's take our question and see what values that they are giving us. So they want us to find T, the length of time. So already our formula needs to have t in it, right? So let me write down the different formulae that we could possibly use, right? So we have v is equal to u plus at, that's the first one. S meaning distance, ut plus a half at squared. Again, we have another s, a half into u plus v. And then v squared is equal to u squared plus 2as. So these are all our kinematics formula that we could possibly use, right? So let's see which one will make the most sense to use here. Right, so in our question we have t, so that automatically takes out the third one. The third one doesn't, and the fourth one as well. There's no t in those formulae. So how we could use it, right? All right. So reaches a speed of 64.8. So this is v, and u is obviously 0, right? Because it's from rest. So we have, oh, we do have a v in this one. So already we have our formula we need to use. See how easy? And obviously g, gravity, is our acceleration in this case, right? Okay, so now that we have our formula, v is equal to u plus at, all we have to do is plug it in. Oh, but first we need to make t the subject of the formula, right? So to move this u to the other side, it will be v minus u. And then just need to divide by a. So t will be equal to v minus u all over a, right? Now, very important here is that your a, acceleration, is in meters per second squared, but your velocity is in kilometers an hour. And we can't have that, all right? We cannot have that. So we need to change kilometers per hour to meters per second, right? All our units need to be the same. So how do we do this? Well, in 1 kilometer, there's 1,000 meters. And in 1 hour, there's 3,600 or 3,600 seconds. So therefore, in 64.8 kilometers, there'll be 64.8 multiplied by 1,000, which is that, right? And per hour, 3,600. So 0, 0, 0, 0, and 36 could go into 648. I believe it's 18 times. Let me just check that for you. Divided by 36. Yes, 18 times, right? So therefore, our final velocity v is actually 18. So t will be equal to 18 minus 0 all over, and acceleration is 10. So t is 1.8 seconds. Okay. The next question is determine the distance that the carriage falls. All right, so now they're asking for s. So let's go back up to our formula here and see which ones we could possibly use. Now we can't use the first one, there's no s in that one. However, there are s's in second, third, and fourth. Now remember we are given the acceleration, we are given v, u, and t as well, right? So let's not use the third one, because the third one seems to be a very simple one that doesn't have any acceleration in it. We want one where we have everything that we want to use. So therefore we could either use the second or the fourth ones. So let's use both of them and see if we get the right answer, right? So the first formula, s is equal to ut plus a half at squared. And then we have the second one, v squared is equal to u squared plus 2as. And we want to find s. So I think this one is obviously the easier one because s is already the subject of the formula. So it's just to put in the values, right? So remember, u is 0, that's the initial velocity. Obviously, carriage will be stopped when people go in, all right? So 0 into t Well, the t is 1.8. Remember, we just calculated the t, right? 1.8. And 0 pi over 1.8 is still 0. Plus a half, the acceleration is 10. And t squared is 1.8 squared. So this is going to be 0. And a half by 10 is 5. And then we could use our calculator to work out the rest. So let's see what we have here. So we have 1.8 squared, that's 3.24, multiplied by 5, 16.2 meters. Don't forget your units, right? Okay, that was easy enough. Let's see if we use the other formula, if we could get the same value. So already, let's see what we have here. So remember, v is 18, right? So v squared is 18, u squared is 0, plus 2 into 10, and then we have the s. Okay, no problem. So let me work out the numbers first. That seems to be the easier thing to do. So 18 squared is 324. Then we have the 0, and 2 by 10 is 20 by s. So to make s the subject of the formula, we just divide 324 by 20. And if you do that, s is 16.2 meters. So no matter which formula you use, you will get the right answer. Okay. All right, I believe this is our last example here. So very simple. Just put your SI units that you need to learn, right? So force obviously is the Newton. Linear momentum, if you remember the formula, is mass by velocity. So mass is kilogram, velocity meters per second. And state Newton's third law of motion. Again, we don't need to waste time on this one, right? We know it. Okay. A Caribbean airplane is on its way from the Piaco International Airport to the Grantley Adams International Airport. It flies horizontally mid-flight. With the aid of a diagram and using Newton's third law of motion, explain how this happens. So I can't draw, but you could probably draw. You just need to draw a plane, right? With the wings. I don't know how to draw the wings. Okay, so the wings and the weight of the plane with gravity, right? There's a down force there, right? And then the wings now, because of Newton's third law of motion, because there's the down force, is an equal and opposite force on the pushing up on the plane. Okay, so this is how Newton's third law really helps the plane fly horizontally. All right, so what this is the weight here for your labeling, and we call this the lift. That is the equal and opposite force. Okay, and here you just need to explain Newton's third law, right? Body A exits outwards on body B, you know it. Okay, define the term linear momentum. So this is very simple, right? So linear momentum is the product of a body's mass by its velocity. Now this is different from the law of conservation of momentum, which says that the total momentum before collision is equal to the total momentum after a collision. So don't be confused when they ask you to just describe linear momentum. That's just describing the formula, okay? All right, so here's a momentum question. An 8 kilogram ball traveling to the east at 10 meters per second collides with a 2 kilogram ball traveling to the west with a velocity of 5 meters per second. So after the collision, they move together. Okay, so in these questions, it's best to draw a diagram to help you out, right? So they're using cardinal points. So west and east, right? Traveling to the west, traveling to the east. So the 8 kilogram ball is the heavier ball, right? So this is the big ball here. 8 kilogram is traveling in this direction to the east, right? At 10 meters per second. Now it collides with a 2 kilogram ball and it's traveling to the west at 5 meters per second. So one is obviously bigger and faster and heavier than the other, right? Now what it says, this is before the collision, right? Now after the collision, the two of them kind of link together. So therefore their mass would work as the same, right? So 8 kilograms plus 2 kilograms would be 10 kilograms, right? And then they will both move in this direction, obviously, because this big ball is pushing that one to that side, right? So they want us to determine the final velocity that they move with. So now that we have drawn our diagram, we know what to do. So the law of conservation of momentum states that the total momentum before, so I could write that, is equal to the total momentum after. So the total momentum before, we'll have to do them separately, right? So the big ball and the smaller ball. So remember, momentum is mass by velocity. Okay, so for the 8 kilogram ball, it's going to be 8 multiplied by 10, because it's going at 10, right? Plus, now we have to do the smaller, plus, right? So 2 kilograms, but if we are moving in the direction of the big ball, we need to consider that the smaller ball is moving in the opposite direction to us. So it is not really moving at 5 meters per second, it is moving at minus 5 meters per second, okay? That is what vectors mean there. Remember, vectors have a direction. This is not speed, this is velocity, okay? So it's going to be 2 multiplied by minus 5, right? So that will be the total momentum before. And now this is going to be equal to the two of them combined, so the mass will be 10 multiplied by v. We don't know what v is, right? That's what we're trying to find. Okay, so let's work it out. 8 by 10 is 80. And then 2 by minus 5 is minus 10. And that's going to be 10v on that side, right? So 80 minus 10 is obviously 70. Is equal to 10v. And to find v, we just need to divide by 10, right? So v 70 divided by 10, which is 7 meters per second. And that is your final answer. So this was a very short video detailing the Newton's 3 laws, kinematics formulae, as well as linear momentum and the law of conservation of momentum. So I hope it was helpful to you.